All right, probability stats review, test review video, just a few short questions. The test will open on Monday for this first module, and it will close Wednesday at 11:59. I will open up the second module on Thursday. Second module will run a little bit different than this first one now that I'm used to Canvas, and it's going to run at a little faster pace, and we'll be out of probability and stats here pretty soon. But for this, I haven't received any feedback from you on the quizzes, examples, or the quiz or anything such as that. So online office hours, nobody stopped by, which again, it's optional, so nothing against you. But I didn't get any questions in email or online office hours or in the announcements as a reply. So I'm going to make the assumption, like a mathematician would, I'm going to make the assumption that you understand the material up to this point. So what I've got on this short slideshow and what I'll work through with you here on this presentation is a few additional problems that are like the ones that'll be on the test. So let's go ahead and get started and get out of this chit-chatty. Here we go. All right. So what have we covered? Well, we have covered how to find the probability of an event given that another event has occurred. So conditional probability. We have covered how to distinguish between independent and dependent events in the context of problem sets. And we have talked about how to use multiplication rule to find the probability of two or more events occurring in sequence and to find those conditional probabilities. Excuse me. I don't know why it's doing that. There we go. All right. Took me a second on my dossary to get it moving forward. So let's take a look at these problems. Determine if the events are independent or dependent. So let's look at this first one. I'm going to change the color of that. I did not like the color of the arrow. So let's look at the first one. Tossing a fair coin 4 times and getting 4 heads, and then tossing it a 5th time and getting a head. Well, all we're trying to determine here is whether tossing the coin 4 times in and of itself and then tossing it a 5th and getting a head, whether those two sets of events excuse me, are independent or dependent. Well, the probability of getting a head or a tail with the flip of a fair coin, assuming that it's flipped the same every time, which we do, is 50%. So tossing a fair coin 4 times and getting 4 heads, the probability of each one of those getting heads 4 times was 50%. We did a problem in a previous video like this one, just not this many flips. So then when you toss it that 5th time after already getting heads 4 times, you're equally likely to either get a head or a tail on that last flip. So these are independent events. The first 4 flips do not affect that 5th flip at all. And please excuse my voice. I've been sick over this last week. I've lost a little bit of my voice, so if it cuts out here and there, that's just a function of my throat being just still a little bit raw. All right, the second one, selecting an ace from a standard deck of 52 playing cards, and then selecting a jack from the deck without replacing the ace. Well, selecting an ace, I'm going to go ahead and do a little bit of writing up here. Selecting an ace, let's go down here, from a standard deck of 52 playing cards. There are 4 aces in any standard deck, so it's 4 out of 52 is the probability of that particular event. Okay? Now, if the second event is to select a jack from the deck and you did not replace that ace, there are 4 jacks, but instead of there still being 52 cards, there are now 51. You have affected the outcome of the second event based on the fact that you didn't replace that card. So these are dependent events. That second event is dependent on the first one where you didn't replace the ace. Erasing. All right, we looked at the second. Let's look at the third. Excuse me. Getting high grades and being awarded an academic scholarship. This one could probably be debated, but I think in a normal world of human beings and regular students, in order to be awarded an academic scholarship, you need to get high grades. That's just the bottom line. So getting the academic scholarship is dependent on getting these high grades. So those are dependent events. Again, I think in a debate class, you could probably debate this one. You could probably find some examples of students who got an academic scholarship who did not get the highest of grades. And then you would have to use semantics and define what high grades were. That's actually I like using that problem a lot in my regular face-to-face class because it opens the floor for discussion on how to present data in a debate. I'll leave it at that. But it just straight across the board, they are dependent. All right. See if I can get Doceri to move me along. No, why would it? I think it's going to. There we go. Yay. All right. A typical problem with multiplication rule. Your roommate asks you to buy toothpaste and dental rinse, but does not tell you which brands to get. The store has 8 brands of toothpaste and 5 brands of dental rinse. What is the probability that you will purchase the correct brands of both products? Now, this also makes an assumption. This makes an assumption that your roommate only likes one particular type of toothpaste and one particular type of dental rinse. That could change, but we're going to make that same assumption for this simple mathematics class problem. So if you go to the store and you're selecting one brand of toothpaste and one brand of dental rinse, and you have to get it correct, and your roommate only likes one brand of toothpaste and one brand of dental rinse, then your probability of getting, let me write this out. Your probability of getting the correct toothpaste is 1 out of 8. So there's one correct choice, and there's 8 choices that the particular store sells. Okay? So the probability of getting the correct dental rinse, boy, I'm losing my writing on this iPad. 1 second. Dental rinse, there's only one correct choice because your roommate only likes one particular dental rinse. And there were how many selections of those? There were 5. So it's 1 out of 5. Okay? So the probability of you being absolutely correct in this sequence of events, first choosing the toothpaste and then choosing the dental rinse, or vice versa, commutative property kicks in because it doesn't matter which order you do them in, you're still going to multiply. They still come up with the same product. So if you choose dental rinse first and then the toothpaste, you're still going to come out with the same answer. So in the case of this particular problem, it looks like this. I'm just erasing because I kind of run out of room there. You're looking at the probability of event A and B. Well, that's just the probability of A times the probability of B. This is a sequence of events. They are dependent. They are independent events, and we're just going to multiply those as they occur in sequence. So the probability of A, and we'll let A be probability of toothpaste and dental rinse. So we'll let A be the probability of getting the right toothpaste, and the toothpaste was 1 out of 8. Put a little X. And then the probability of getting the right dental rinse was 1 out of 5, which when you multiply this, hopefully, I don't know your skills, but hopefully you know you just go straight across. So it's 1 over 40. And 1 over 40 actually accurately gets you 0.025. So you got about a 3% chance of getting that correct. But this is the multiplication rule. So that's the setup, and that's the mathematics and the computation. All right. Oops. Now let me go to the next slide. Shoot. Okay, it didn't move. Yay. Let me get this out of the way. All right. The last problem for this short review for the test. Again, keep in mind that I'm willing to do 14 million of these. If you tell me that you've got issues, I'll work with you till I'm blue in the face to make sure you understand it. So if you don't understand any of this, or you're missing a piece, how to start, how to compute it in the middle, do I do a tree diagram, that kind of stuff, send me an email. Put something in the announcements to say, hey, I just need a few more. I'll be glad to do them. Not an issue. All right, last problem. Your sock drawer has 18 folded pairs of socks with 8 pairs of white, 6 pairs of black, and 4 pairs of blue. This is your sock drawer. That's what it looks like. What is the probability without looking in the drawer? So in other words, you are randomly selecting. So what is the probability that you randomly select a black pair and then either a blue or a white pair? All right? Well, we're going to think about this. Number one, if I reach in there without looking, the probability of getting a black pair is equal to what? Well, we have 18 total in there, and we have 6 that are black. So, 6 out of 18. All right? The probability of choosing blue, we don't need these independently, but I'm going to work them out anyway. Of choosing blue would be 4 out of 18, assuming you haven't already made a choice with non-replacement. Next is going to be the probability of drawing, what was the third color? Blue. No, I did blue. White, sorry. Probability of drawing white. Well, you've got 8 pairs of white and 18. 8, 14, 18. Yeah, that's it. That's all of them. So there are your individual probabilities. Now, we've got a little bit different problem. It says, what is the probability, without looking in the drawer, that you will first select and remove a black pair, then either select a blue or white pair? Now, in this case, these are dependent events because of this word right here. You remove a black pair. It never tells you that you replace it. So you're going to first select and remove a black pair, then you're either going to select a blue or a white pair. Okay, no problem. Let me erase this off, and I will finish it off. Just by straight numbers, no, I'm not going to do that. Let's go back to the form. What's the probability that A and B, where A is selecting a black pair and B is selecting a blue or a white pair? Now, this can get quite complex with that word or, but in this case, it's a very easy because we're just dealing with numbers of socks in a drawer. So the probability of removing a black pair is the probability of A. And we're going to multiply times the probability of B, which was selecting either a blue or a white pair. No problem. What is the probability of selecting a black pair? First selecting and removing a black pair. It was, I think I have this committed to memory, but I don't. 6 pairs out of 18. Okay? I'm going to multiply that times probability B, which is selecting blue or white, which makes them the same now. Because blue or white doesn't matter the color. You could select, the only ones you can't select, the complement of those two grouped together would be the black socks, in which there's only 5 pair left. So the probability of getting a blue or white pair next, you've already pulled out the black pair. There's 4 blue and there are 8 white. So you've got 12 out of 17. And then you figure it out. You go from there. So I go, I go 6 divided by 18 times 12 divided by 17. About 0.235. I'm going to round this to 3 decimal places. You may ask yourself why, and it's because I'm the instructor and I can choose 3 decimal places. But in this case, we're not flying a rocket to the moon, where if we were off by a 10,000th of a point, it would make a difference. And we're not filling prescriptions where we might hurt somebody. So for the purpose of this class and the room I've got left on my iPad, we go 0.235. And that's it. So hopefully this helps as a final review. And again, I cannot emphasize enough, please let me know if there are any types of problems that I've given that you are unsure of, that you just don't know how to work. Let me know before the test, and we will finish up the module this week. If I hear from you with some extra problems, I will get with you either one-on-one or as a group and send something back to the modules with some answers to your questions. All right, thanks for watching this, and I look forward to interacting next week. Thanks.